Numbers are the fundamental building blocks of mathematics, forming the basis for understanding quantities, proportions, and patterns. Their relevance extends far beyond academia, permeating our daily lives in countless ways. From basic counting to complex calculations, number systems provide a framework for quantifying and interpreting the world around us. In this essay, we will delve into the fascinating realm of numbers, exploring their various forms and the essential operations that govern their interactions. We will begin by examining the foundational concepts of whole numbers, decimals, and fractions, understanding their unique properties and how they interrelate. Building upon this foundation, we will explore essential arithmetic operations such as percentages, ratios, and proportions, which are crucial for solving real-world problems. Furthermore, our exploration will encompass the principles of algebra, where we will unlock the power of algebraic identities, manipulate elementary surds, and delve into the graphical representation of linear equations. As we progress, we will venture into the captivating world of geometry, exploring the fundamental properties of triangles, circles, and other polygons. We will uncover the elegance of geometric theorems and learn to calculate areas, perimeters, and volumes using the principles of mensuration. Our journey will then lead us to the intriguing realm of trigonometry, where we will unravel the relationships between angles and sides in triangles, master trigonometric identities, and tackle problems involving heights and distances. Finally, we will touch upon the basics of statistics and probability, learning to represent data effectively and calculate measures of central tendency. At the heart of our numerical journey lies the system of whole numbers consisting of 0, 1, 2, 3, and so on. These numbers form the basis for counting, ordering, and representing quantities. As we delve deeper, we encounter fractions and decimals, which allow us to express parts of a whole or quantities that fall between whole numbers. Fractions, represented as a ratio of two whole numbers, provide a way to denote parts of a whole. Decimals, on the other hand, utilize a base 10 system to express fractional parts using a decimal point. Understanding the relationship between fractions and decimals is crucial, as they are often used interchangeably in various mathematical contexts. Mastering the four basic arithmetic operations, addition, subtraction, multiplication, and division, is paramount when working with whole numbers, fractions, and decimals. These operations form the bedrock of countless mathematical concepts and are essential for solving a wide array of problems. Beyond the four basic operations, we encounter percentages, ratios, and proportions, which play a vital role in expressing relationships between quantities. Percentages, denoted by the symbol percent, represent fractions out of 100, simplifying comparisons and expressing changes in quantities. Ratios express the relative size of two or more quantities, while proportions establish equality between two ratios. These concepts are instrumental in various fields, including finance, statistics, and everyday life. Venturing further into the realm of mathematics, we encounter algebra, a powerful tool that utilizes symbols and letters to represent numbers and quantities. Algebraic expressions allow us to generalize mathematical relationships and solve equations, unlocking a new level of problem-solving capabilities. One of the key concepts in algebra is the use of identities, which are equations that hold true for all values of the variables involved. These identities serve as fundamental building blocks for simplifying expressions and solving equations efficiently. Another important concept is that of surds, which are irrational numbers expressed as square roots of non-perfect squares. Understanding how to manipulate and simplify surds is crucial for working with more complex algebraic expressions. Geometry, the study of shapes, sizes, and properties of figures in space, complements algebra by providing a visual and spatial dimension to mathematical concepts. We begin our exploration of geometry by examining basic geometric figures such as points, lines, and angles, which form the foundation for more complex shapes. Triangles, with their three sides and three angles, are fundamental geometric shapes with unique properties that we will explore in detail. Circles, defined as the set of all points equidistant from a central point, possess intriguing properties related to their circumference, diameter, and area. Section 4. Unveiling the power of mensuration. Mensuration, the branch of mathematics concerned with measuring lengths, areas, and volumes, bridges the gap between theoretical geometry and practical applications. Using the principles of geometry, we can calculate the area of various two-dimensional shapes, such as rectangles, squares, triangles, and circles. Each shape possesses unique formulas that relate its dimensions to its area, allowing us to quantify the space enclosed within its boundaries. Similarly, mensuration enables us to determine the volume of three-dimensional objects like cubes, rectangular prisms, cylinders, cones, and spheres. By understanding the relationships between the dimensions of these objects and their volumes, we can calculate the amount of space they occupy. Mensuration finds applications in various fields, including architecture, engineering, construction, and design. Architects use mensuration to calculate the area of floors, walls, and roofs, enabling them to estimate material requirements and costs. Engineers rely on mensuration to design bridges, buildings, and other structures, ensuring their stability and structural integrity. Section 5. Delving into trigonometry, heights, distances, and relationships. Trigonometry, derived from the Greek words trigonon, triangle, and metron, measure, is a branch of mathematics that explores the relationships between angles and sides in triangles. This fascinating field finds applications in various areas, including navigation, surveying, astronomy, and physics. At the heart of trigonometry lie the six trigonometric ratios: sine, cosine, tangent, cosecant, secant, and cotangent, which define the relationships between the angles and sides of a right-angled triangle. These ratios are defined as the ratios of the length of two sides of the triangle. Trigonometric identities, which are equations involving trigonometric functions, are another essential aspect of trigonometry. These identities allow us to express one trigonometric function in terms of others, simplifying complex expressions and solving trigonometric problems. One of the practical applications of trigonometry is in solving problems involving heights and distances. By applying trigonometric ratios and identities, we can determine the height of a building, the distance of the river, or the angle of elevation of the sun. Trigonometry provides us with the tools to measure and calculate distances and angles that are otherwise inaccessible. Section 6. Statistics and probability. Making sense of data. In today's data-driven world, understanding statistics and probability is crucial for making informed decisions. Statistics deals with the collection, organization, analysis, interpretation, and presentation of data, enabling us to extract meaningful insights from raw information. Probability, on the other hand, deals with the likelihood or chance of an event occurring, allowing us to make predictions and assess risks. Data representation plays a vital role in statistics, allowing us to visualize and understand patterns and trends in data. Various graphical representations, such as bar graphs, histograms, pie charts, and line graphs, provide different perspectives on data and facilitate comparisons. Measures of central tendency, such as the mean, median, and mode, provide insights into the typical or central value of a dataset. The mean represents the average value, the median represents the middle value when the data is arranged in order, and the mode represents the most frequent value. Probability, often expressed as a fraction or a decimal between 0 and 1, quantifies the likelihood of an event occurring. For example, a probability of 0 indicates that an event is impossible, while a probability of 1 indicates that an event is certain. Understanding probability concepts is essential for making informed decisions in various fields, including finance, insurance, and healthcare.